Hi and welcome everyone on this beautiful Friday day, and we are here with you another live stream from YouTube. And my name is Levent Gürdemir, UTA Planetarium Director, and Jim Bader, Program Coordinator, is co-hosting.
Always sitting back here pushing buttons.
And today we are going to do another sky update. We'll talk about what's going on in the night sky, what you can just see for yourself going outside. And of course, if you have any questions, you can ask in the chat. You can direct your questions and you can interact with us too. So let's see what's going on in the night sky. So if you didn't notice, there is a very bright thing in the sky. I'm not going to say a star because it's not a star. Very bright thing in the night sky towards west and towards south directions. But also we have a full moon night. So full moon is very bright. It is the full moon rises after sunset. So when the sun goes down, you can see full moon is rising from the other direction, which is going to be east direction. And you can enjoy the full moon through the night. It is going to provide a lot of light through the night, and then it is going to set with the sunrise tomorrow morning. So and we will look at some of the bright things. For example, we can see, uh, you know, approximately like southwest direction. Let's turn to southwest first.
All right, we're looking to the directly west.
All right,
Moon
so
is up.
this is directly west, and all right, moon is rising from here. Moon, we talked about it before, right? Moon is not going to appear that small in the sky because our the perception, the brightness perception is kind of giving us an optical illusion that we think that the moon is huge. So moon, yeah, moon covers a lot of area in the night sky, but also because of its brightness, it is going to wash away a lot of area around the moon. And if you are looking at night sky tonight, you may see a few shooting stars, more than usual, because we have Orionid's meteor shower. So it is peaking nowadays. It was maybe a great night to show them, to watch them last night, and it will be another great night tonight. But Orionid is something that you may see. But the full moon is going to be actually ruining a lot of the meteor strikes you may see in the sky, because moon is so bright. Again, it makes dim things impossible to see. So if you happen to see a shooting star at the night sky, feel free to make a wish. And hi Lamia again, good to see you. And is it Jupiter? No, it's not. I haven't talked about Jupiter yet. It is up in the sky. You can see it for yourself, but we'll get to that later. So the moon is the brightest thing. Yes, it is creating a lot of light pollution for us in the night sky, and also the shooting stars. You may just catch a few. Who knows? So in that direction, let's turn to approximately southwest direction. So that's going to be a little bit farther on that side. You can notice a very, very bright thing. So that bright thing, if you see something like this, maybe I need to scoot a little bit over. And here you can see a very bright, where is the constellation Scorpius? So this must be Scorpius, right? So it is not all the way to the horizon. I can't.
Darken the sky a little bit.
Yes, I need that sky darkened a little bit more.
Darken your tail end.
Uh-huh.
Light.
Mhm. Because Jupiter, the Venus, and the star Antares in the Scorpius constellation couples very nice in the tonight sky. All right, so I think it's behind me right here, right?
This is heavens.
All right, so let's zoom into Venus from.
We stayed up late to see the Orion.
Like it's gonna be after midnight.
Yeah. We stayed up really late to see the Orionids, so we like Scorpius isn't up. Scorpius sets at like 9:30.
Okay, yes, but it's
So
in the early sky,
yeah,
and I seen it myself. So after sunset, it is pretty bright, especially Antares. The middle star of Scorpius is very bright in the sky, and it couples greatly with Venus. Oh, right here. So you can see. Well, you are not going to see those lines in the
this
sky.
is about 8 p.m.
This is very close to the horizon. Okay, and you will see a very bright object in the sky. That's going to be Venus. That's not going to be like anything else. Like it's going to be a planet. The planets are so bright. The visible planets are so bright in the sky. You can distinguish them easily from stars. And this is Venus. And here, the star I'm talking about is Antares. It's a red star, red supergiant, in the heart of Scorpius constellation. Scorpius is very easy to identify, but it's going to be close to the horizon, and with the full moon, I am not going to say we are going to be able to see all the stars, but at least we can recognize this shape. And this is like a curly tail of a giant scorpion, as we imagine. And the Scorpius is the name of the constellation. But anyway, Venus is visible, and right next to that, on the little bit bottom, you will see Antares, the red star.
Just for the record, if you live in north of DFW, you may not be able to see this, but as long as there's no major city south of you, you shouldn't have a problem.
All right, so let's turn to south direction, and in the south direction, you will see some two bright lights in the sky hanging, and those are Jupiter and Saturn. We talked about these planets before. They have been in the sky for a while, but one of them is right there and one of them is right here. So you can grab even a small telescope, like a very inexpensive telescope, and you can see the bands, the brown bands of Jupiter and the rings of Saturn. And especially the rings of Saturn is very cool if you are looking at the real Saturn using the real optics, not like an image on the screen. So these planets are very easy to identify too.
Those rings, looking at them in real life, they don't look quite like you'd expect in terms of crystal clear, defined rings. Every time I see them through a small telescope, Levin, I don't know if you agree with this or you've experienced this. I always get reminded of that when Galileo first saw Saturn. He wrote down, it looks like this planet has ears.
Because
that's how I see it.
The telescope he used, we think that the resolution is very low, or for the telescopes, actually we are not using the term resolution, we are using the term magnification. And if the magnification is too low and you try to zoom in to enlarge the object, so what you get is a very fuzzy image. And with the fuzzy image, this planet looked like just grown ears to him. So it was a funny thing.
It's also wild to me that there was a time when people didn't know there was a ring around Saturn. Like that was a time. That was a fact at one point. Oh, there's not a ring. We don't understand. It's just a point of light in the sky. Because now, I mean, planet is synonymous with rings. It's just wild. I don't know.
Yeah. Well, usually the first time sky watchers, when they look at the Saturn's rings through a telescope, they don't think that they are looking at the real planet, and they always blame the astronomers by just showing them fake picture in the telescope. But it is not actually. It is that beautiful. It is just great thing to look at Saturn with telescope.
Definitely.
So there's a lot more in the sky you can see. If you just look above head, there is still summer triangle you can see. The summer triangle doesn't vanish from the sky in the big part of the winter. It is still there. You can find the three big stars. You can identify three bright stars. I think I need to scoot over this direction. And one of them is going to be Vega right over here. And another one is going to be Deneb over here, and the another one is the bright star of Aquila. And this forms a big triangle. And this is not a constellation. Each corner have different constellations. The The biggest one is the Cygnus, the swan. This constellation represents a flying swan. And it is important with the black hole. This constellation is hosting a black hole. The first discovered one was in that constellation, somewhere around here. The astronomers years ago identified an X-ray radiation, and that turned out to be the first time X-ray source in the sky. So they named it Cygnus X1. They did not know what it was, and then later they found out that that was the first discovered black hole. And here is one of my favorite places. If I have a telescope outside, I like wandering around this constellation. This constellation is Lyra, the harp. So yeah, the Greeks imagined it as a harp, but it is sometimes, some people call it necktie shape, yes, and some people call it like the number 8 they see in this constellation. But anyways, right under star Vega, if you just go down in the constellation, over here, when you point your telescope, you will find a surprisingly beautiful object, which is called ring nebula. So nebula is a term that means dust in Latin, and the ring is the shape of this nebula. They also call this mistakenly planetary nebula. So when we say it is still used by astronomers, they call this type of nebulae planetary nebulae, but there is no planet in this. This is not representing any orbit. This is actually a dead star. So yeah, stars die this way, and we see all these colors. If we have powerful enough telescope, we can see all the blue, yellow, and orange, even red colors around it. So what those colors tells us? By physics, the colors tells us how hot the gas is. So yeah, this is a dead star. The star pushed out all the gas and dust out of the star. So all the gas and dust which was contained in the star previously is just forming a big shell around the dead star. So this is what we see, and we can tell which parts are hot and which parts are cold just by looking at the colors of this great nebula. Cygnus, Lyra, and Aquila. Yes, those form the summer triangle. All right, so now
just a bit.
We are going into space. I think we will venture different places.
It's a surprise. Where are we gonna go?
Okay.
It'll be fast, a very fast trip, uncomfortably fast trip.
All right.
Break the laws of physics fast trip.
We like breaking laws over here in the computer environment.
Yes, so, specifically, not real laws.
Yeah, the travel speeds. There's some maximum allowed speed in the space, and that is 186,000 miles per second, and that is the speed of light. We cannot exceed speed of light with the physics we know it, and that would be new physics if we could do that. And I think that we are flying around the great, beautiful looking ring nebula now. And if you know any objects that you would like to see and get close and fly around, if you let us know, we'll be happy to take you there virtually. All right, so let's see what else is on our list to talk today. Those are the things you can see in the night sky. It's always great thing to just go outside. If you have a telescope, just get your telescope with you. If not, that's fine. You can just set off your eyes and still find great things in the night sky. That's the beautiful thing about stargazing. Most of the time, I don't take my telescope outside because it is just easier to use my eyes. And I can identify a lot of bright stars, planets in the sky, constellations, and especially the moon is up there. You don't need anything. You can just take a look at the moon. This is the volumetric version of the ring nebula. As we said, this is just not like a ring shape gas around the star. This is forming a big shell, all the gas and dust. And again, you can identify the colors and you can tell which regions are hotter. And apparently, the inside, the close to the Death Star regions are hotter than the outside regions. There is also a galaxy we can find in the sky. Well, when we just look around different constellations, we can find constellations Pegasus, and then attached to it Andromeda. And inside the Andromeda constellation, there is a galaxy hidden. Unfortunately, it is very difficult to find by just looking into sky with pair of eyes, because that galaxy is so dim, it is actually above the visibility limits. If you find a very dark sky, you can really see this galaxy with your own eyes. But most of the time in the city environment, it is not possible. So you need to use a telescope. So Andromeda constellation is right here. And on the extension of the constellation, you can identify, it is not going to be this big. Again, it's going to be a very dim thing in the sky. And let's zoom it in. This is the closest galaxy. So we are in Milky Way. This is our neighbor galaxy, Andromeda. Andromeda just look like our Milky Way galaxy. It is too far away, but actually it is getting closer and closer as we speak to Milky Way. And if we wait long enough, if you give it enough time, Milky Way will merge with Andromeda galaxy in the future. So this may sound like a secret information I'm revealing here, but this is no importance actually, because this collision is going to start after 2 million years. We do not really care about that. So Lamia says blue is for high temperature. Yes, in the gas law, according to gas law, the hotter gas glows blue, and as the gas gets cooler, it gets in different colors in the spectrum, finally until red. So in between colors like the yellow, green, and all represent different varying temperatures. But because we cannot, there's actually certain temperatures, the very high temperatures that we cannot see. For example, our eyes are not capable of seeing colors beyond violet. And on the other side, on the low side, beyond red. We call it infrared. You hear that term infrared all the time. And my great example, I happen to have a remote control over here. So the remote controls have optical senders, optical the bulbs in front of them. This is actually just a bulb. Sends codes to the TV to change channel. So when you press something on it, you can, some cameras are, I'm not sure if you are able to see in your computer screen, the cameras are able to pick up the light, and you can literally tell this is actually getting lit. But if you just look at it, you won't see any light, because the light coming out of this is infrared light. We cannot see. Infrared represents even cooler temperatures. Similarly, above violet, our eyes cannot detect higher frequencies. So if the gas is glowing hotter than violet temperatures, then we will not be able to see it. But we can see from violet to red, all the way to the spectrum. Great. We got lost in space.
All right. I was just I got a little distracted there, but we were showing emerging galaxy.
Yes. Galaxies
Sadly,
do
now,
merge.
directly
Yeah.
behind.
If you give it enough time, galaxies do merge with each other. So, but usually the common question asks, when we merge, like we are not going to be here, so we are not going to we are not planning on living another 2 billion years, right? So we are not going to be here. We are not going to see that the Milky Way starts merging with Andromeda galaxy. But when the two galaxies collide and merge, This is not like a car crash. It is not an immediate process. That takes another billions of years. And surprisingly, the galaxies are too low dense that the coincidence or the chance of two stars colliding with each other when two galaxies merge is actually very low. What happens is the process is very smooth. When two galaxies merge, they combine, change their shape, and they form completely different shaped galaxy. We see that all the time when we look at the universe, especially Hubble telescope spotted a lot of merged or merging galaxies in space. All right, so what is next? We are running out of time, I guess.
Yeah, we are running out of time. I'll reset the sky and let's go back to where we were before we started this little mix.
Okay, let's turn our direction to north because I would like to mention a few things about the north direction and how to find it, and maybe we can talk more about the north and North Star, and perhaps a little bit celestial navigation next week, but we can set the base this week. I see also another question. Can stars collide during this merging? Yes, they can collide, but usually the probability of two stars bumping into each other very, very low. What happens is the stars may get close to each other, and this close contact, close encounter will trigger the gravity forces and change the stars flying directions in the galaxy. So, and that will result into the entire galaxy changing its shape. So this is what happens with the galaxy merging. So if we are in the north direction, if you are looking approximately at the north direction, we will find this constellation very low in the sky. So this constellation is the Big Dipper. We can easily identify this because it looks like a big spoon in the sky. And from the big spoon, if we use these two stars, I call them guide stars because they guide me to a very special star. And the way to do that is I find from this star, just draw a line to this star and do that 5 more times, or pretty much go in the extension of this line, and you find a very tiny star located right here. This star is not very bright star. This star is not a very easy to find star. This is my only way to find it, and this star is called the North Star. So North Star is part of another constellation called Little Dipper, and you will see it just looks like the Big Dipper, but it is only in the opposite direction. So why do we call this North Star? To find out, and we'll talk more in detail next week, this star is not very special star, not special star at all, other than it's being a Cepheid variable star as a star, but this star is just happened to be sitting at a very special point. And that point is called North Celestial Point. The North Celestial Point is very close, not exactly on top of the North Star, but very close. For that reason, this star is called North Star. But there are very interesting things about the North Star. First, by looking at the North Star, we can find the north direction. So that's very easy. Now, you may argue that your smartphone can do that too. Yes, no arguing that. But imagine people had a history of thousands of years traveling around the world on ships. And they didn't have sophisticated navigation devices. They didn't have GPS. They didn't have electronic compasses. They didn't have at one point in time compasses at all. So for that reason, they were still able to find their way to different continents, right? I mean, the ships, they started from England, London, and they traveled all the way to the United States, or they departed from India, and they were able to find their way all the way to the United States. So this was happening because they knew how to navigate using the stars. These techniques today called celestial navigation, and the North Star is important and integral part of it. Uh, you turn your face to the North Star and you immediately find the north direction. Using the North Star, you can also find which latitude you are in on Earth. Well, to pinpoint your location, when you open a map on your phone is able to first, it gets it gets the lead the GPS signal, reads the GPS signals, and then do little calculation and immediately pin down your location on a map. To do that, you need two numbers. One is what's called geographical latitude. The other one is longitude. So the North Star's elevation immediately tells, and I will talk about it, how to find it next week, your geographical latitude. And for longitude, it is possible North Star has nothing to do with the second coordinate longitude, but you can use some other bright stars to do it. And plus, we know from the history, the North Star was not always the North Star. If we go back to the time that pyramids were built, like 5,000 years ago, they aligned some of the holes in the pyramids with what they call North Star. But that North Star is different. It is not this one. Jim is consistently pointing out another star in the sky. And we'll talk about why ancient Egyptians considered another star in the sky North Star, and why we consider this star North Star. So it's a little teaser for next week, and we'll get back to you with all the answers next week. And all right, let's take a look at some of the questions we received. And is there a way to know north in the southern hemisphere? No. The pole, the only pole you can see in the southern hemisphere is the southern pole. And there's another pole, but it is southern pole. You cannot see the North Star, so you cannot identify which direction is north by looking at the stars if you are in the southern hemisphere. And we'll talk about next week how North Star changes in the sky when we travel in the world vertically, which means from north to south, south to north. The North Star's elevation is going to change, and when you get to the equator, the North Star will be a star in the horizon. And when you pass the equator to the south direction, the North Star will remain under the horizon all the time. So we'll talk about North Star next week. And if you have questions and or some of the things that you would like to bring up, please be here next week or let us know in advance. And always, if you like this video, just like it and subscribe. Of course, subscription brings you notifications when we start streaming. But we'll be here next week, Friday. And also next week, we will be here, not here on YouTube, but we'll be on Facebook on Wednesday. All right. See you next week. Have a good weekend.
See you, everybody.